In this video, I'm going to talk about the cost of pre-training and retraining large language models. So what kind of models are we talking about? Of course, we are talking about models like ChatGPT. Recall what ChatGPT is, or the GPT-3 from which it's derived. They are actually pre-trained models in that you give it a database and that it learns from that, and then it is frozen in time. And so whatever questions that you ask later on is always based on whatever it had learned. It does not learn anything from that point onwards. So in that sense, these are pre-trained models. The question that I'm going to address is, what about retraining them? And that becomes relevant, as you will see with this example. So I asked a very simple question to ChatGPT yesterday. And I said, who is the Prime Minister of the UK? And ChatGPT answered, as of my knowledge cutoff date was September 2021, the Prime Minister of the United Kingdom was Boris Johnson. Recall that we had gone past Boris Johnson several times already. And then it goes on to say, as of 1st March, the Prime Minister of the United Kingdom is currently unknown to me, as I am an artificial intelligence language model. Now, that's not quite the right answer. It should have said, because I am not getting updated on recent information. It does say what I've highlighted in red. It says, I do not have access to real-time information. So this is the lacuna of ChatGPT. Now, I don't want to pick on just ChatGPT, but it's the same problem with all models of this kind. So when I asked, for example, another question about who won the World Cup in 2022, it gave me the answer that the World Cup was won by France, but then it says in 2018. So what is the main technical problem here? The main technical problem is this. What you have typically in a traditional software is that if you have a bug in your software, you fix the problem in the source code itself. Fair enough. Now, what if you try to do the same sort of thing with a model that large language models are made of? Recall that these models have many, many billions of parameters, which are all hidden from us, that need to be tweaked. And we really don't know which one is doing what. So in theory, the model can be retrained, but you have to retrain the model everything from scratch. And that's a very expensive business, and it also takes time. Let me illustrate that with one example. So here's the model called Bloom. You may not have heard about the Bloom model because it's fairly recent and it has not been that popular yet in terms of these kinds of models go. So what it purports to do is to do language translation with a large number of languages. It has all kinds of information from each of those languages. I'm going to come to that in a second. But training of Bloom took 3.5 months and consumed over 1 million computer hours on a French supercomputer called Jean. Now, the computer itself was named after the French education minister who was killed by the collaborator in 1940. The price tag of the computer that French government actually bought was in the neighborhood of $500 million. And the training cost for this Bloom was about $50 million. Now, technically, it didn't have to spend all that money because most of the time that was used for developing this model was done by volunteers. Volunteers are actually, most of them are big names. If they had charged on a commercial rate, it would have it would have cost in the neighborhood of $50 million. So what does that model do actually? It is, as I said, a language model, and in its database, it has 46 natural languages and 13 programming languages, which then, using that, it uses a Megatron machine Megatron software in order to develop this model. So what kind of languages does it have? It has languages that you normally do not see in these kinds of models. For example, it includes Akan language, which is in a language in the border of, in parts of Niger and Congo in Africa. And for that, it has about 700,000 bytes of data, which is very small. Arabic, which has 74 billion bytes of data. Assamese, which has 290,000 million bytes of data. Basque, Bengali, Catalan, and the list goes on. I have stopped it there so that, but there's a whole bunch of other languages. There are in total dozen Indian languages. Bengali is one of them. And if you notice there, Bengali has about 18 billion bytes. Catalan also has in the same neighborhood of bytes in the process. But notice what happens when you go from a non-European language. Even though both are Indo-European languages, Catalan is spoken by about 8 million people, whereas Bengali is spoken by 300 million people. So there's a qualitative difference in terms of how much spread each of these languages have. Now, in fairness, even though Catalan and Bengali are both listed here as Indo-European language and macro area of Eurasia, being a native Bengali speaker, and I have some smattering of Catalan as well, because I speak Spanish well as well, there's a qualitative difference in terms of, if you know Bengali and if you know Catalan, there's not a whole lot of common things in there, even though they are both classified as Indo-European languages. So what I'm trying to say is that these kinds of classification do not quite tell us how close or how distinct these languages are. So this language is a step in the right direction in order to get to a better handle of a larger collection of languages across the globe. Now, let me try to illustrate the problem with what we can do trying to fix this model. So ChatGPT has stopped the clock in September 2021. So what does this model do? Basically, if you have a sequence of tokens, think of them as words, x1, x2, xt minus 1, then it tries to predict what xt is going to be. That's the basis of these models. And then there are bells and whistles, how it does that and so on. But in order to try to update these models, what you need to do is to tweak the model. So in our example, the PM of the United Kingdom, if you say that it is Rishi Sunak and you include that in that model, then it will try to do, if you do it by, roughly speaking, underfitting the model, you will do it by looking at a sequence of words that come before Rishi Sunak, and then you try to fit that in that context. And so it learns a series of words, if you like, and then the last word would be Rishi Sunak. There's also a problem of overfitting the model. And if you overfit the model, it produces a more generic kind of thing that overfitting does. It might end up saying that Rishi Sunak is the Prime Minister of India. So obviously we do not want that. The overfitting is a problem because it says some completely wrong things, and underfitting is also a problem because unless those string of sequence come in first, it's not going to give us Rishi Sunak at all. So are there different approaches to fix this problem? Yes. One approach is taken by what is so-called the MEND model, which is used by a group of Stanford researchers. So what they do is, in order to do this kind of sequence setting, it uses what is called a gradient decomposition, and that's the basis of all large language models. And the gradients are more compact in reducing the dimensionality of the problem, essentially. So what it does then, it filters all the neural connections to identify what needs to be updated and what does not have to be updated. So this is what this particular MEND model tries to do. So it does that, and in the process, and it has been tested with models of 10 billion parameters, it reduces overfitting and underfitting to some degree. The only problem is that it does have a cost. The internal consistency is lost. In other words, it might start to say, you know, Rishi Sunak as the Prime Minister of England and of the UK, and then it will suddenly say Rishi Sunak is a criminal, for example. The other model that has been developed, where it does overcome this problem, what it does is looks at the very, very nonlinear model that all the ANNs have. They are very nonlinear. What it tries to do is to see any linear connection in between those nodes, and that often, it seems, exists. So technically speaking, the in-context learning, or ICL, matches the minimum base risk predicted on noisy data sets. And that's a mouthful. So roughly speaking, what it does, if you think of, you have a regression model, however, you know the independent variables are highly linearly correlated. What do? Well, you typically traditionally you dropped one variable and then run the model again. A better approach is to run what is called a ridge regression. So this is in a sense parallel to that kind of ridge regression idea in a different context. So in summary, what we can say at this point is that there is no clear and easy pathway to get rid of this problem. The only thing you can do is to try to develop some fixes, if you like, fixes on the edges, and those fixes have obvious trade-offs. So you trade one kind of problem with another set of problem. What is more desirable remains to be seen.